Okay guys, so here we got another video. Let's get going here. So, on this problem, they're giving us the histograms. You will notice they're all symmetric or approximately normal like we would like it. They represent sampling distributions where we know that p hat comes out to be 0.7. And we're told our sample size is 84. Well, one of the things we hopefully remember is that when I have a normal curve, or approximately normal curve, we know the mean and median should be dead center here, right? And the standard deviation will be somewhere about a third to halfway down each side. It's going to be at the inflection point where curvature changes direction, but that's where our standard deviation is. Okay, somewhere about a third to halfway down each side of our approximately normal curve. So, hopefully we at least understand that. So, what's the only thing we really need to do is we need to find the standard deviation. We're going to do p times 1 minus p over n and then take the square root. So in our case, we're taking 0.7 times 0.3 divided by our sample size 84. And then we're going to take this result and square root it. So we now know if p hat is 0.7 with a sample size of 84, we expect our standard deviation to be 0.05 or close to that. So if you look at the curves, guys, notice how this one's centered at 0.7, 0.7, 0.7, 0.21, that's no good. And by the way, guys, I want to remind you that when you do these multiple choice, as you progress through your answer, eliminate bad answers. Notice this one's 0.84 or something, no good. So now we're down to either A, B, or C. So again, if here is the mean, we know the standard deviation should be around here somewhere on each side, right? Standard deviation should be about here, about here. Now, if we look here, notice 0.63, that's a difference of what, 0.07? If we look here, 0.7 to 0.73, that's a difference of 0.03. Here, we have a distance on each side of 0.05. Aha! That's what we predicted should be the standard deviation. So the correct answer for 30 should be A. All right, let's move on to the next one. Now, guys, how many times have we talked about if I make the sample size larger, our standard deviation goes down? Right? We get more precise. We get less variability. Okay? So, if you look at our choices here, we're supposed to go from smallest to largest by sample size. Does everybody understand that this must be the largest sample size? Or, sorry, I have it backwards. This has the largest standard deviation, so it will have, therefore, the smallest sample size. Okay, so in other words, this one would be like maybe sample size 10. This one here, see how there's less variability here. It's gotten narrower, right? It's not as wide as this one. It's less spread out, B is, right? Well, because it's gotten narrow, this one would have a sample size that is actually larger. The larger the sample size, the smaller the standard deviation. So this one may be a 50, let's say. This one, look how all the data is close together here. And therefore, this one should have a large sample size. This one may be 100 or 200, okay? Again, we can't tell exactly what the sample sizes are, but, because remember, guys, whenever we do graphs like histograms and box plots, one of the tricks is having you think about the sample size or actual raw numbers. You can't do that. But what we can do by looking at the shape and comparing them, we know that this one should be from a smaller sample size with more variability, whereas this one on the other extreme, because they're so close together and it has a very, let's say, a smaller standard deviation, it's going to have a larger sample size. So from smallest to largest, we're going to go C, B, A. And that's why the correct answer is E. All right, one more. Guys, we talked about this in a previous video. Notice how we're averaging 850 and 1340, right? Well, if I want to combine those two, because, you know, as a realtor, you're going to sell houses in the suburbs, you're going to sell houses in the city potentially. They're obviously different price points. So how do we combine our average weekly sales? Is we're going to add them together. So notice if I add 850 with 1340, I should average 2190. Now, hopefully that makes sense. If I average 850 and then 1340 in a different part of town, together I should average out to be around 2190. They're sum, right? Now, what about standard deviation? So, by the way, I can eliminate A and B, right? I know the mean sum should be 2190. Now, what about standard deviation? Well, guys, remember, we're going to combine by Pythagorean theorem. C squared is A squared plus B squared. Of course, C, therefore, will be the square root of A squared plus B squared, right? So, we are going to take the 260, square it, add that to the 390 squared. This is my A squared plus B squared here. That sum we're going to take the square root of, and this is the combined standard deviation. So it's around 468 to 469. So if you look here, guys, they rounded off to 469. So that's why the correct answer is D. And that's it. So guys, hopefully some of these essential concepts are getting into your memory banks now. Again, if you have any questions, please bring it up in class so we can have a nice discussion about it, guys. Every day has got to be focused towards the AP exam now for sure, right? Even though we have been, now it's even more critical, let's say, right? Every day we got to make it count. See you in class.